Hello, this is Mr. Henry, and welcome to lesson 0.4. In this lesson, we are going to estimate irrational numbers without a calculator. So the calculator you have, you can go ahead and put aside. We're not going to use them for this lesson. I may pull them out a time or two just to check and verify, but all the work we're going to do will be without a calculator. Okay, so the question says, how do I estimate irrational numbers without a calculator? Did you know that a perfect square is a number that is the result of a number multiplied by itself? So that means like if I take 3 times 3 and I get 9, 9 is called a perfect square. If I take 5 times 5 and get 25, 25 is a perfect square, because this number is the result of a number times by itself. It is also because only perfect squares can make a perfect square with that many objects. So for example, if you had 9 objects, here I'm using squares, I could make a perfect square out of it. Here we go. 9 is considered to be a perfect square because if you had 9 objects, you could arrange them to form a perfect square. See? Other perfect squares, like 4. You had 4 objects, boom, 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 4 M&Ms. You can make them into a square. If you had 16 objects, maybe we're using Skittles now. Perfect square. There's 4 on each side. That is 16. Same thing works with 25 and 36 and 49. All of those are called perfect squares. But this doesn't actually work for all numbers of objects. Like, would it work for 12? There's no way you could actually take 12 objects and make a perfect square from it. So there's 12. That's a rectangle. It's 3 this way, it's 4 this way. And you could try another arrangement of them. Now you've got 6 and you've got 2. You can just put all 12 in a straight line. That's not a square. There's no actually way to take 12 of these. And you can say, oh, but what if you like space them out? Well, that's kind of cheating. If you like put an extra space in here so it looks like they make a square, it's still there's 4 on this side and 3 on that side, okay? So they're different number of objects. Only perfect squares you could arrange to form a perfect square where each side is the same length or has the same number of objects. Okay? And it says here what other number objects could be arranged to form perfect squares. And I said a few minutes ago, and we'll see a lot of them today. So we have 2 vocab words here today, and we've actually talked about perfect square even in previous lessons. I've brought it up, and I said we're going to get to it later on. That's now. So a perfect square is a number that when you take the square root of it, you get a whole number answer. And I have shown you many, many times how you would type that on the calculator. So this is one of the few times on this page is when we're going to use the calculator. So if we're going to take the square root of, say, 16, we take second, then the x squared button, gives us our square root, type the number, equals, there you go. Okay, so that is how you take the square root of a number. And a perfect square, when you square root it, will always give you a perfect answer. No decimals, no fractions, no junk. A perfect cube we have not really talked about. A perfect cube is a number that when you take the cube root of it, you get a whole number answer as well. Now, I did talk about a long time ago, the first few lessons or so, when we first started taking square roots, I said, be careful of this other square root that has like this x in front. Because that does not do a square root. That does a cube root. So I'm going to show right now, and you can follow along with me so you can understand how to do this on your calculator as well. I'm going to take the cubed root of 81. So on my calculator, here's what we have to hit. We're going to hit 3 second, and not this x squared button. If we did that, what we're actually doing is 3 times the square root of 80. We don't want that. This is going to give us 2 different answers. We need to basically have this 3 inside the square root. So I'm going to use this x to the square root button, this caret key. That takes the 3 and it puts it in there for the x, like this. Now if I hit 81 equals junk, that number would be an irrational number. Now if I take the cube root of something that does work out, say 3 second square root 64. Oopsie. I did the wrong thing. 3 second special root, this one. 3 second caret 64. We should get 4 as an answer. There we go. Because 4 cubed, which is 4 times 4 times 4, is 64. And this cubed root thingy is the opposite of cubing. 4 cubed, cubed root. So if you cube root 64, you're basically asking yourself, well, what number is that thing times itself 3 times to get 64? And the answer is 4. Okay? So we have perfect squares, we have perfect cubes. And we're going to do most of this lesson, almost all of this lesson, without a calculator. So goodbye, Mr. Calculator. It was nice to see you. All right, so let's get to it. So now, the question says, for each irrational number below, estimate its value without the use of a calculator. Now, in order to do that, it would be helpful if we could make ourselves a little table. So this little table I'm going to make is of perfect squares. Now, this is something that you can always do on any homework, any test, any quiz, anything. If you're having trouble with your perfect squares and perfect cubes, you can simply make this little table. And you see, I just have a bunch of boxes. You can even do this without boxes. So basically what I'm going to do is at the top, I'm going to write down 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoa, that's not a 9. 9, 10, 11, 12. Okay, so hopefully you got the pattern there, right? Now, the bottom here, we're going to put down what is 1 squared. 1 times 1 is 1. What is 2 squared? 2 times 2 is 4. What is 3 squared? 3 times 3 is 9. And I'm not going to write this little squared guy for all of them. 4 squared. 4 times 4 is 16. 5 times 5 is 25. And take a second, see if you can fill in the rest of the table. I'll give you like 3 seconds here. All right, that was a little more than 3 seconds, but I gave you a little bit of a head start. 6 squared is 36, and 49, 64, 81, 100, 121, 144. And if you're able to beat me to the end, awesome job. So now we can use this table. This is all we need to answer all of our questions in this lesson. Well, we'll make one more table on the next page, I think. But this table is really what we need to answer our questions. So we want to figure out what is the approximate value of the square root of 80 without using our calculator. So we look at our table. So the way this table works out is if we would take, there we go. If I would take the square root of this number, I would get that for an answer. Square root of 4 is 2, because 2 times 2 is 4. The square root of 64 is 8, because 8 times 8 is 64. So the square root of 80, I'm going to look down this row and find which number here is the closest to 80. There it is. So I know if I take the square root of 81, I'm going to get an answer of 9. Now, on the other side of 80 is 64, my other perfect square. And I know if I take the square root of 64, I'm going to get 8. So if you think of this like on a number line, this answer gives you 8. This answer gives you 9. Where would this answer fall? Would it be closer to 8, right in the middle, closer to 9? Well, definitely very much closer to 9. This square root of 80 is almost going to be the same value of square root of 81. It's going to be like way down here. So if you had to take a guess, you're going to say this number is about 9. About 9. And that's what we can say. We are approximating. We are not giving exact answers. If we wanted an exact answer, we'd use the calculator. Now, I'm doing this because I can show. And if you want to type in just to show, to check, yes, that is about 9. Okay? Please don't cheat yourself and just blow through all these questions with a calculator, because the problems become too easy and you're not learning anything. You're not doing the lesson the way it should be taught. The lesson is, the skill is, can you estimate these square roots and cube roots without a calculator? All right, letter B, 96. So I need to find out what numbers here surround 96. What are the two perfect squares that are lower and higher? So out of this list, 96 would fall right there, between these two. So I know the whoa, what the heck is that? It's an N. Let's try to make a square root symbol. The square root of 81, square root of 100. On my number line, this is 9, this is 10. So where does the square root of 96 fall? Is it closer to 9? Is it closer to 10? Is it right in the middle? Well, here, it's closer to 10. So I'm going to say the square root of 96 is about 10. It's approximately 10. That's all we're doing. We're seeing which two perfect squares are around that number, and then we are estimating its value. So I'd like you to try these two, letters C and D. Go ahead and write them down on your paper. Give them a try. When you're ready to continue, hit play, and we'll go through it together. All right, so the square root of 45. If I'm looking at my list up there, the square root of 45 falls right between here. So my two perfect squares that surround 45 are 36 and 49. Square root of 36 is 6. See? Square root of 49 is 7. See? So where does square root of 45 fall? Well, square root of 45 falls closer to this side. It falls closer to the 7 than it does to the 6. So I'm going to say the square root of 45 is about 7. Use the arrow so I can do the next problem. All right, next one. 14. So I'm looking at my list. 14 is right about here. So my two perfect squares are 9 and 16. 14 falls between 9 and 16. Square root of 9 is 3. Square root of 16 is 4. This guy, 14, falls closer to this way. It's closer to 16 than it is to 9. So the answer here is about 4. Now, after you've done a problem, if you want to check your work, now's the time you may take a calculator out just to check. Second square root 14 is 3.741. Now, we would never be able to get all those decimals correct in our heads with our brains. That's why we're approximating. That's why I'm saying it's about 4. Okay. Now, let's get a little bit more tricksy. Those were pretty easy. Now, we can still do these problems. They're just a little bit harder. So we're still not using a calculator. So here I want to find out the 4 times the square root of 32. Okay, so I'm going to take 4 times by whatever value I determine square root of 32 to be. So I'm looking at my list. Square root of 32 is between here and here. Now, it's definitely closer to the 6. So I'm going to say square root of 32 is about 6. I'm approximating. I'm estimating. So if I take 4 times about 6, I'm going to get about 24. That's as close as we can get. Now, calculating, 4 times second square root 32 equals, we're off by a little bit, 22.6, we said 24. That's okay. It's an estimate. It's close. Letter F, square root of 38 divided by 3. Okay, so I'm going to take whatever I estimate square root of 38 to be, and then take that divided by 3. So square root of 38 is between 6 and 7. Well, is it closer to the 6 or is it closer to the 7? It's closer to the 6. It's almost 36. It's just a little bit higher. It's definitely 38 is closer to 36 than 49. So this number is about 6. And then if I take a number that is about 6 and I divide by 3, I'm going to get a number that is about 2. It's an estimate. Now, I can tell you this number is going to be a little bit bigger than 2. It's going to be 2 point something, because square root of 36 is a little bit bigger than 6. So when I divide by 3, I'm going to get something a little bit bigger than 2, but just by a little bit. Okay, here are 2 for you to try. Letters G and H. If you could, please go ahead and pause the video. Try these 2 on your own. When you're ready to continue, hit play, and we'll go through it together. All right, letter G, letter G, letter G. All right, so I'm going to take 45, divide by whatever I determine that to be. So square root of 27 here is, he's right about there. He's pretty darn close to this 5 here. Pretty close to 25. So I'm going to say square root of 45, or square root of 27 is about 5. It's pretty close. That's my closest whole number, my closest perfect square. So now when I divide, simplify, 45 divided by 5 is 9. So this guy had a value of about 9. Letter H was negative 2 times by the square root of 120. So square root of 120 is right about there. That's the closest perfect square. So that means the square root of 120 is going to be really darn close to 11. Just a little bit under, a little bit less than 11, but it's pretty close to 11. And so when I multiply here, negative 2 times by 11 is going to be negative 22. And there we go. So that's my approximate value. And just for good measure, we haven't checked one of these in a while. Negative 2 times the square root of 120 should give us about negative 22. And look how close we were. We were very close that time. Now, we are approximating perfect cubes, no longer perfect squares. You see this little 3 up here? That changes the problem. That's not saying this is not 150 divided by 3. It's not like old school division like this. This is not what we're doing. Okay? This perfect cube, we're trying to figure out what number times by itself, times by itself, times by itself 3 times is 150, or at least close to 150. So what we're going to do is we're going to make a table. We can't use a calculator again, so we're going to make a table. So on the top, fill in your numbers, and we'll go from there. So 1, 2, 3, 4, 5, 6. And you notice this table is a lot smaller than my previous table because perfect cubes get big really, really fast. So let's see. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 3 times 3 times 3. 3 times 3 is 9. Times 3 is 27. You see how these getting big getting bigger much, much, much faster. Keep going. 4 times 4 times 4. 64. 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. Notice I'm not doing this with the calculator. I can still reason this out. I can, even if I didn't know 25 times 5, I could go, okay, 25 plus 25 plus 25, and add 5 of them together. That's doing 25 5 times. You know, old school multiplication addition rules. 6 times 6 times 6. 6 times 6 times 6. 6 to the third power. 6 times 6 is 36. And 36 times 6, you can just write it out if you need to. 36 times 6 and do long multiplication. 36, and that's 18, 19, 20, 21. 216. You could add up 36 together 6 times. I mean, however you choose to do it is fine. But just reason it out. Okay, this is without a calculator. So now that we have our table made up, where would this cube root of 150 fall in this list of numbers? Well, it would fall in here. Is it closer to 125 or is it closer to 216? It's closer to 125. It's closer to the 5. So I'm going to say this guy is about 5. I know it's going to be a little bit bigger than 5 because 150 is bigger than 125. So it might be 5.2 or 5.3. I don't know exactly what it is, but it's a little bit bigger than 5. Okay? The cubed root of 22. So 22 would be right about there on my number line. So I'm going to say this number is definitely much closer to 3 than it is to 2. 22 is much bigger to 20 or closer to 27 than it is to 20 or to 8. So this is about 3. We're just getting it close, just getting approximations. That's all we're doing. We'll get to the hard ones later on. Okay, if you could please try these 2 problems. When you're ready to continue, hit play, and we'll go through them together. Okay, so we have cubed root of 100. So 100 would fall in here. Now, is it closer to 4 or is it closer to 5? It's a bit closer to the 5. It's 25 numbers away from here and like 40 numbers away from here. So we're going to have to say it's closer to the 5. This is approximately 5. But it's probably more likely in the middle-ish. It's probably like 4.6, 4.5 something. I'm going to check it now. If you'd like to follow along here, again, just you see how the cube rooting is done in the calculator, you can do that with me. So we're going to take 3, second special root, the caret key, 100. 4.64. So you see it's closer to the middle, but still, if you're rounding this to the nearest whole number, you'd have to round it up to 5. This would not round down to 4. Okay? So again, the key presses were 3, second, caret, the special root of 100. Okay? Letter D, the cubed root of 5. So based off this, the cubed root of 5 would be down here, closer to 1 or closer to 8, and a little bit closer to 8. So I'm going to say this guy is about 2. So these are easy ones. Now we're going to get some more complex problems, some uglier ones. So it's the same dealio. We got the same table up top, and we want to figure out what are the values of these expressions without using a calculator. So I know my answer here is going to be a negative. I know that I'm going to take whatever the cubed root of 9 is and then divide it by 2. So on my table up here, let me put my beautiful arrow back I had before. There we go. On my table, the cube root of 9 is right around here. It's a little bit bigger than 8. So the only thing I can guess is the cube root of 9 is about 2. So the cube root of 9 is about 2. And then when I take 2 divided by 2, I'm going to get about 1. So this expression here, the whole expression, has a value of about -1. This is about 2. 2 divided by 2 is 1. Don't forget your negative. Letter F. This is 6 times the cube root of 3. Now, I guess it's worth showing the calculator here. This would be a mistake. If you did this, 6 3 second special root 25, like you try to do like we did before with square roots, that's going to give us a very wrong answer. Like before, if this was a square root, we'd do 6 second square root 25. And we just kind of put them all together. Well, that doesn't quite work when we have this cubed root thing. Here you'd actually have to type in 6 times. Actually, I'll be honest, I don't even know if this is going to work either. 6 times 3, the cubed root of 25. Oopsie, oopsie, oopsie. Something didn't work there. There we go. I don't even know if this is the right answer. So let's check. Let's see if the calculator even gave us close to the right answer here. It looks like that would be the right thing to do, but I'm not positive. So I know it's going to be 6 times, and then whatever this cubed root gives us. So the cubed root of 25 is over here, a little bit less than 3. And so I would approximate this guy to be about 3. 6 times 3 is 18. I think that was actually what we had here a second ago. Now, if I wanted to type this into my calculator, if I wanted to be 100% sure that I was correct in doing this properly, my calculator didn't make any stupid mistakes, here's actually what I would type in. I would do the cubed root first. I would take 3 second caret to get the special root of 25 equals. Then I would take that answer times by 6. I don't even know if that's what we had before. It's 17 point something. But this is the way I would make sure that the calculator's not doing something wrong. So if I did this, I in my head, I could imagine a calculator giving me a different answer. I could imagine it trying to do this part first and getting 18 and taking like the 18th root of 25 and getting something horribly wrong. Okay? So if in doubt, do it the way that you would do it by hand. If you were doing this by hand, you would do this cube root first and then take your answer times by 6. If you had to do it on a calculator, type it in like that. But we are not using a calculator if we can. So please try these two problems without a calculator. Try to estimate their values without a calculator. When you're ready to continue, hit play and we'll go through them together. Okay, so here's what we got. We've got the cubed root of 200 divided by 3. So the cubed root of 200 is over here. Definitely closer to the 6 than the 5. Definitely closer to 216 than 125. So my estimation for cubed root of 200 is going to be about 6. Divide 2. 6 divided by 3 is 2. Letter H, the 8 times the cube root of 60. So cube root of 60 is a little bit less than 64. So the cube root of 60 is about 64. So I'm going to say this cube root of 60 is about 4. 60 is close to 64. The cube root of 64 is 4. So this guy's also about 4. Multiply it out. You get 32. And if you wanted to try on the calculator again, let's try this one, just to make sure we know how to do this on the calculator. I would do 3 second caret to get my special root of 200. I would even, this calculator's slow, 3 second caret, there you go, of 200. I would get my answer first, then divide by 3. If you did it the other way, and you did 3 second caret 200 divided by 3, it happens to give us the right answer, but I could imagine it wouldn't. I could imagine the calculator trying to do this, 200 divided by 3 like that, and giving us a wrong answer. Because this, 3 roots of 200 divided by 3, these are not the same problem. These will give us 2 very different answers. And I wasn't sure which way the calculator would do it. So, if in doubt, just to be careful, do it the way you would do it by hand. Take the cube first, answer, then divide by 3. Okay? Example 3. Now, we're going to do a little bit of solving equations. Now, these equations are going to be simple for now. We're going to get more difficult later on. We're actually going to have a whole unit, well, a couple units, on solving equations later. So these are going to be simple. So here's what we need to do. To solve this equation, we need to, or let's start this way. To solve the equation, we need to do the opposite of what's happening to the variable. My variable here is being cubed. It's y cubed. So to cancel out that cubed, we are going to, I call it uncubing, which is cube root. This cubed root here and this y cubed here, these exponents actually cancel each other out. You have to use the same exponent. So I'm using a cubed root to get rid of a cube. Here, I'm going to have to use a square root to get rid of the squared. And in case you didn't know, square root actually has a little invisible ghost 2 in here. We don't write it because we, as math people, understand that if you don't put a symbol in there, it means it's a square root with a 2. If it's anything other than a 2, you have to put the number in there. But a normal square root symbol has a 2. So in this case, this guy and this guy would cancel out. That's what we're going for, okay? Come on, marker. So here, back to letter A. When we cube root this problem, the cube root of y cubed, these guys cancel, so we have just y equals. That's kind of our goal. That's what we wanted. We wanted to get the variable by itself. But hopefully you've seen in the past that when you do something on one side of an equation, you have to do it to the other side as well. So when you cube root this other side, the cubed root of 27, if you need to go back and look at your paper, the cubed root of 27 is 3. Exactly 3. Now, how can we check if we did this problem right? It's actually very easy. We can say, you know, it says here that y is 3. So if I take 3 to the third power, I should get 27, right? Well, try it. 3 times 3 times 3 is 27. This math works out. This y value of 3 is the correct y value to make this equation true. So we have the correct solution. Letter B. So when I square rooted here and I square root here, always everything on both sides, these exponents cancel. Squared and the square root cancel. I get just m. When I square root the 36, square root of 36, if you need to, what number times by itself is 36? Oh, 36. The answer is 6. If I go back up to my earlier table, square root of 36, 6. And check it. Just do, like, it takes 5 seconds to check this in your head. Is 6 squared 36? Is 6 times 6 36? And you go in your head. Yeah, it is. You're good. Okay? If you could, please, try out letters C and D on your own. Pause the video, try them. When you're ready to continue, hit play, and we'll go through them together. Okay. So, since this is a squared, x squared, we're going to square root both sides. The square root and the squared cancel, which makes this just x. That was the goal. On the other side, when you take the square root of 121, what number times by itself is 121? The answer is 11. So the square root of 121 is 11. Letter D may have looked a little bit different because the variable was on the other side of the equal sign, but we still do the same thing. We are going to, well, because he is cubed, we are going to cube root both sides. The cube and the cube root cancel out, so we get just h equals. And over here, we're trying to find the cube root of 64. So what number times by itself 3 times is 64? Now let's play pretend for a second here. Let's play pretend you're on a homework problem, or a test, or a quiz. You don't have a table, or heck, maybe you don't understand the tables I made there. And you're trying to find out what number times by itself 3 times is 64. Well, you can make a little table yourself, or you could, right now, you could just start going, you know what, okay, 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3. And you could actually just start doing this on your own. 4 times 4 times 4. See, 4 times 4 is 16. 16 times 4 is 64. Ah, you found it. 4 times 4 times 4 is 64. So the cubed root of 64 is 4. Make a table. That is a valid problem-solving strategy. If you don't know it off the top of your head, and you don't understand the tables we made up here, all these guys, and you're not quite sure what to do, well, this is kind of like guessing and checking. You say, well, is it 3? You take 3 times 3 times 3. Nope, that was too small. Is it 4? And you find out that's what it is. Okay? Don't be afraid of doing a little extra work on the side of the page if it means you got the right answer. Okay? A little bit harder. So I've got 2, then you've got 2, and then I think we're going to move on to some problem solving. So letter E here. Now what's different about these problems than the previous ones is this has, well, a little number out front. Now, you should, by now, be familiar with one-step equations. I mean, this is 8th grade stuff. You should have done this in 7th grade and probably even 6th grade. So the first thing we need to do here in letter E is we need to get rid of this times by 2. We need to get the variable by itself. And hopefully you remember, the opposite of multiplying by 2 is you divide by 2 on both sides. Now, what we have is this. I divided by 2 here, they cancel. I divided by 2 here, 32 divided by 2 is 16. Now, we can square root. You can't square root until the k squared is by itself. You can't square root if it's being multiplied by something or added by something. You want to have it just k squared. Or just, in this next problem, we want just to have b cubed. That's going to be our first step, to make this 4 go away to get here. Then we can cube root both sides to get our answer. Okay? So in letter C here, since this is k squared, we're going to square root both sides. Square roots cancel out squares. Cube roots cancel out cubes. Square root both sides, and this cancels out. And the square root of 16. What number times by itself equals 16? Go through your times tables ahead if you need to. Look at the tables. The answer is 4. 4 times 4 is 16. The square root of 16 is 4. Letter F. So I said that this was our goal, to turn this stuff into that stuff. So basically, we need to get rid of that plus 4. And hopefully you remember from previous years, the way you get rid of a plus 4, the opposite of adding 4 is you subtract 4 on both sides. And so you subtract 4 on both sides, these cancel out. You got your b cubed equals 129 minus 4 is 125. And now we can cube root. See, it's b cubed, so we need to use a cube root. Cubing and cube rooting are opposites, and they cancel. E equals the cube root of 125. What number times by itself 3 times is 125? Try You can use guessing and checking. You can look back at previous examples. You go, you know what? I know 4 was too small, and so was 1, 2, and 3, so you could just keep going from there if you need to, and try 5, and try 6, and 7, and 8, and you're going to find out these numbers get big very quick. The answer is 5. 5 times 5 times 5 is 125. So the cube root of 125 is 5. Right. Here are 2 for you to try on your own. These are letters G and H. If you could, please pause the video, try them right now. When you're ready to continue, hit play, and we'll go through them together. All right, so hopefully the first thing you tried here in letter G was to divide by 3. We had to cancel out this called a coefficient, the number in front of the variable. Cancel him out to get m squared equals 27 divided by 3 is 9. And now we can square root. See, it's squared, so we square root both sides. The square root and the squared cancel, so we get m equals. And the square root of 9, what number times by itself is equal to 9? The answer is 3. Letter H. We want to get rid of this minus 8. So to cancel out a minus 8, we're going to add 8 to both sides. We get r cubed equals, so 117 plus 8. Let's see. 8 plus 7 is 15. 1. And that's 2 and 1. 125. Now look at that. He's old school addition. All right, so 125. So we have r cubed equals 125. So some number times by itself 3 times is 125. What is that number? Well, let's cube root. That is how you uncube something. So what number times by itself 3 times is 125? Well, look at that. We did it right here. The cube root of 125 is 5. Get the variable and exponent by itself first, then square root or cube root to get the exponent gone. Problem solving. Example 4. It says the volume of a cube can be found using this formula. That seems important. Usually if they give you a formula, you need it for the problem. So there's a formula. And just because I want to, I'm going to draw myself a cube because they're talking about a cube. And I'll make sure I have everything labeled and pretty and perfect. All right. Where S is the length of a side. Okay, yes. So S is the length of a side. If the volume of a cube is 216, so the volume of this cube is 216 yards cubed, what is the length of one side? And if you're looking at that going, I have no clue how to do this, let's look at the information they gave you. They gave us, well, they didn't give us a picture. I drew the picture. And we know the volume of this is 216, and S is the length of a side. They also gave us a formula that takes in a volume and a side. Well, usually if they give you a formula, you're going to use it. And the first thing you do with the formula, after you copy it down, is plug in what you know. And we know in this problem the volume is 216. It says so right there. It said so right there. And it wants us to find what is the length of one side. That was the S. S is the length of a side. S is the length of a side. That's the thing we're trying to find. So now that we've plugged everything in, this problem is very doable, very reasonable. Our variable is cubed. So to solve that problem, we're going to uncube it. We are going to cube root both sides. That makes these guys cancel out, and you get S equals. On the other side, the cubed root of 216. is, oh, you got tables back here to look at. You can look at any of these previous tables. If you don't like the tables, you got your brain. What number times by itself is 216. And you should find the answer, no matter what method you choose, is 6. The cubed root of 216 is 6. So that would mean the length of the side of this cube is 6 yards. And just to double check yourself, if we go back to the volume, we knew the volume was 216. If the length of one side is 6, does this math work out? Is 6 cubed equal to 216? The answer is yes. Yes, it is. So this is the correct answer. Letter B. Your friend Frank gave you 32 Skittles and told you to arrange them in a square. How many Skittles would you have to eat before you could arrange the remaining Skittles in a square? Okay, so here's what I'm going to do. I'm going to make a little circle here, and I'm going to make them orange because that's my favorite color, Skittle. So there's my orange Skittle. And then I'm going to turn him, Infinite Cloner, on. Come on. Clone. So I'm going to drag out a bunch of Skittles. There's 1, 2, 3, 4, 5, 6, 7. I guess I should start trying to arrange them into a square now. 8, 9, 10, 11, 12, 13, 14, 15, 16. So right now I have a square that's 4 by 4. So I'm gonna, when I add another row here, I'm gonna add another column here to try to keep this into a square. So I have 16, 17, 18, 19, 20. There's 5 on this side now. 21, 22, 23, 24, 25. It's back to a square. 26, 27, 28, 29, 30. It's a rectangle. This side has 6, this side has 5. So it's not a square, so I'm going to go back. That's 30, 31, 32. Okay, so that's all the Skittles I have. So I need to make this a square. Currently it's not. So even if I eat this one, yummy, yummy, those two gone. I'll leave them over here. So if I've eaten these 2 Skittles, that's still not a square. That's a rectangle. This is 5, that's 6. So in order to make this a square, I'd have to eat these guys as well. Oh. That way they can fit on the page. Now if I eat all of those, now this has a length of 5. That has a length of 5. That would be a square. So how many Skittles would I have to eat? I'd have to eat 1, 2, 3, 4, 5, 6. I would have to eat 7 of the Skittles in order for this to be a square. Now, this was drawing a picture. Another way you could have done this without drawing a picture is if you knew your perfect squares. It would have been a lot quicker and easier, and you could have said, okay, so I have 32. What are my 2 perfect squares around 32? You can go back to one of the tables, or you could just start making them in your head. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is not 6. 3 times 3 is 9, Mr. Henry. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. And you go, okay, that's too many. I don't have 36 Skittles. I can make a square out of 36, but I don't have that many. I only have 32. So the biggest number that I can make a square out of using this many Skittles is 25. And so to get from here down to there, you'd have to eat 7 Skittles. 32 minus 7 is 25. Okay, so there's one way using a picture. That's one way using a table. Perfect squares. Letter C says, your younger sister wants to make wooden block towers in the shape of perfect cubes. She only wants one tower of each size and has 100 blocks to use. How many block towers could she make at one time with her 100 blocks? I'd recommend you make a sketch, maybe looking back at some tables. The hint here is she wants them all to be perfect cubes, and she only wants one tower of each size. So go ahead, pause the video, try this on your own. When you're ready to continue, hit play, and we'll go through it together. All right, so she has 100 blocks to use, right? So the smallest tower she could make, because she wants to say how many block towers could she make at one time, the most number of towers she can make. So the smallest tower she can make is just one block. That uses one block. Now, that's a perfect cube. The next perfect cube she could make, each side would be made of 2 blocks. There you go. So it's a perfect cube again. This side has 2, this side has 2, that side has 2. Well, how many blocks is that? 2 times 2 times 2 is 8. The next biggest one she'd make is if all the sides had 3 blocks on it. That would look kind of like a Rubik's Cube, if you know what a Rubik's Cube looks like. And that's going to be hard for me to draw pretty. Close enough. That's actually pretty decent. It's better than I thought I was going to get. So each side has 3 blocks on it. So how many blocks would be in this whole cube, in this whole tower? 3 times 3 times 3 is 27. Okay, how many blocks have we used up altogether? Because she has 100 to use. How many have we used? We used 1 plus 8 plus 27. So that's 9. 9 plus 27 is 36, right? 9 plus 27 is 36. I think so. Okay, the next biggest tower she can make would have 4 on each side. Now, I don't know if you've seen the pattern that's happening here. Oopsie, didn't mean to do that. I don't know if you've seen the pattern that's happening here, this 1, 8, 27. That looks very familiar and very much like this. 1 cube takes 1 block. A block with 2 on each side, 2, 2, 2, is made of 8 blocks. A cube tower with 3 blocks on each side, 3 times 3 times 3 is 27. I don't really need to even draw the 4th block. I can just make a quick sketch if you want and say it's 4, 4, 4. I know that's going to be 64 blocks. Now, if we add these all together, I know if I add this next tower, that's going to be way too big. She's not going to have enough blocks for that. She only has 100 blocks total, and this one tower of 5 blocks would take 125 cubes, little blocks, to make. She doesn't have that many. So the answer is either going to be 3 or 4. So let's see. If we add these all together, 1 plus 8 is 9. 9 plus 27 is 36. 36 plus 64 is 100. So look at that. She would actually have the perfect number of blocks to make 4 towers. She can make a block of 1 cube on each side, a block with 2 cubes on each side, a cube block with 3 blocks on each side, and a cube tower with 4 blocks on each side. Letter D. Last of these problem solvings. It says there are two numbers between 0 and 100 that are both perfect squares and perfect cubes. What are those two numbers? So think back, maybe even look back at your tables. What are the two numbers between 0 and 100? They're both perfect squares and perfect cubes. Go ahead, pause the video, see if you can find out those two numbers right now. When you're ready to continue, hit play, and we'll go through it together. And the answers are 1 and 64. 1 is a perfect square, because if you take the square root of 1, you get 1. If you take the cube root of 1, you get 1. They give you perfect answers, no decimals involved. 64 is also a perfect square and a perfect cube, because if you take the square root of 64, you get 8. And if you take the cube root of 64, you get 4. Those are the only two numbers that are both a perfect square and a perfect cube. Every one of the other numbers from our tables would only be one or the other. And there are probably more than just these numbers, but the ones less than 100, these are the only two. Last problem. Example 5, multiple choice. It says, which of the following irrational numbers is closest to 0? So let's see here. If I use some of my table, now these numbers are all fairly, whoa. These numbers are all fairly small. So my perfect squares, because I need square roots for these three, and I need a cube root for him. So actually, let me do the cube root first. So if I'm estimating about what number times by itself, times by itself, times by itself gives me close to 9. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 was 27. So the closest one was about that. So I'm going to say this guy is about 2. That's not terribly close to 0, but we'll keep going. Actually, this is a cube root as well. Okay, cube root of 24. Let's keep going. So that's about what times what times what is negative 24. Ooh. So, well, we know it's not 2, because 2 times 2 times 2 is 8. And if I use negative 2 times negative 2 times negative 2 would give me negative 8. Okay, so what if I tried negative 3? Negative 3 times negative 3 times negative 3 would be negative 27. That's pretty close. I don't think I'm going to get anything closer than that. If I try negative 4, I'm going to get negative 64. 4 times 4 times 4 is 64. So I think the cube root of this is about negative 3. Okay, so he's definitely not going to be my right answer, because positive 2 is closer to 0 than negative 3. So I can already cross off this one. I know he's not right. So now I'm down to these other two to see if they're closer than about 2. Negative square roots of 10. So what number times by itself is about 10? Well, 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. That's really darn close. 4 times 4 is 16. So I'm pretty sure it's going to be, this is the closest one. So I'm looking for a negative about 3. Or you could even flip the abouts and the negatives. Make this about negative 3, because there's the negative out front there. So it's about negative 3. So no, it's not him. He's closer. Letter D. Square root of 2. So this is, what number is about 2? 1 times 1 is 1. That's pretty close. 2 times 2 is 4. That's too far away. So the square root of 2 is about 1. And then if I take that times by 3 3 times something that's about 1, it's about 3. No, it's not him. So I'm going to say letter A is the closest because the other ones are all about either positive 3 or negative 3, and that's the only one that's about 2. So you see how this estimation could actually maybe even save you some time if you don't have a calculator handy or nearby. And you can do a lot of these problems without a calculator, just using your brains, just using your head, and a little bit of effort and determination. Summary says, without using a calculator, give 3 irrational numbers between 5 and 6. So you're going to do that on your own. This has been lesson 4, 0.4. Thank you for watching.